All right, great. Nice to be here. I'm also looking forward to the pizza, so we'll make this quick. No, I'm just kidding. My name is Pontus Wärnestål. I'm from Halmstad University, where I work as deputy professor in information technology. And I've been working in particular with service design, so the softer part of tech, focusing on how are digital technology used, how has it created value, and what are the user experience things we can do with technology. I started my AI angle on this already in when I did my master program in cognitive science, because back then AI was an integral part of cognitive science, and we meshed that up with language technology and interaction design. So that became my profile, and I started at a company called Nokia Home Communication, and this was I'm old enough to have lived a life before the iPhone. So Nokia was the state-of-the-art company to work in tech back then. What we did at Nokia, and this is 2001, 2002, we did the so-called smart home, where we had a TV guide where you picked up a remote control with a microphone and a push to talk button, and you would interact with the television content and you would get personalized recommendations. Does it sound familiar? This is what Apple TV did 2015. We were way too early with this. Netflix at the time were still shipping physical DVDs to customers, so we didn't have any data to train on. We didn't have any of those kinds of algorithms, but still we did personalized recommendations using natural language and voice. So I actually hacked this prototype in on a Linux machine using Lisp, the old AI language for managing the dialogue and the speech recognition. So that was fun times. And then I moved into more regular service and UX design for a couple of years, both in consultancy work and also in-house. But I've also always had one foot in academia. So I've done research part-time and I've worked in industry part-time. A couple of years ago, we started an education program, a bachelor program in Halmstad University called Digital Design and Innovation, with a focus on UX design and service design. And we realized that there was a piece missing, and that was AI for UX designers, because AI has always been a very technical domain owned by machine learning experts and back-end programmers and data scientists and so on. But we realized that in order for AI to become valuable, we need a layer between the users and the tech, and that is the user experience design and the service design. But people, and I know that some people are in that space now, so I'm being a bit blunt here, but some people moving into a UX design career is because they love tech, but they don't like the math involved in tech. So they aim for that. That means that within the UX and service design field, you still need to understand enough about AI to make use of it for value creation services and activities. So that's why we introduced the course. And then when I looked around for course literature for that course, there was nothing. So I had to write the book as well. So it's on student literature now, Designing AI-powered Services in English and Design av AI-drivna tjänster in Swedish. And that we used for 3 years now, I think, or 2 years now, with some success. So that's my background and my angle towards AI. And just to get a sense of the room here, I guess we have both developers and designers and so on. How many identify as designers? Okay, great. How many identify as developers? Okay, good. And who else? Product manager. Okay, great. So we have some bridge people between the tech and the UX and so on. So great. So some of the things I will talk about will be, very basic for some of you, and then for the rest of you, you might come to other content that you feel like, yeah, I already know this. So just bear with me. We're a diverse crowd in the room. So the definition of AI, right? Anyone knows the definition of AI? Exactly. Yeah, exactly. So it's a trick question. There is no really definition, and you will not find an agreeable definition. That's why I like this. John McCarthy, one of the pioneers, he said this: as soon as it works, no one calls it AI anymore. And I think that's really telling, um, uh, because it seems to be that rainbow at the horizon, and we keep pushing the boundaries for what we consider to be AI. In the 60s, regular relation databases, SQL, they were part of AI research, and then when that got well understood, it tends to be lifted out of the AI field and it becomes its own thing. And so we're constantly pushing the boundary, and AI is always the thing that we haven't done yet, so to speak. But we can also say that if AI doesn't work for humans, it doesn't work. So that's another definition, right? If it doesn't serve humanity in some sense, I would claim that AI doesn't work. So we need to continue to work on it until it makes value for humans. We can still ask what AI is, and then we need to qualify what kind of answer do we want when we ask that question. Well, one question could be where I'm from, cognitive science and philosophy of mind. What is intelligence? And then by knowing that, we can say, okay, so what's synthetic intelligence or artificial intelligence? We will not go into that discussion now. Perhaps after the pizza is a good time to go into the philosophy of that. I mean, what do we mean by human level intelligence? What do we mean by general intelligence, super intelligence, and so on? This is the domain of Max Tegmark and those kind of people, right? How does AI work technically? That's another question we can ask when we wonder what AI is, and that become very more concrete and tangible. That's, how does GPT do what it does, right? Then we can talk about transformers and pre-trained networks and so on. That's not really what we're going to discuss either tonight, even though that's really interesting. Rather, I think we are moving towards these kinds of questions. What does AI, whatever it is, what does AI mean for business and value creation? And what does it mean for the future of work and society? And for me as a designer, the core question will be, how do we work with AI as a design material to create better services? And that begs the question, well, what is a better service? Better than what and for whom and why and in what context? Those are the tricky questions that I enjoy working with. The notion of viewing AI as a design material means that we can view it as something we can sculpt and create and modify, because the impact of any kind of service or activity will only be as good as the combination of the tools, the skills, and the design material we have at hand. And AI is one of the possible design materials that we can use, along with other tools and methods. I've toyed around with this image for some time now, and it seems to work in some contexts. You're free to challenge it, but in my head, design is constantly evolving. As a species, we've spent a lot of time here considering physical products as our design output. And I actually consider pixels on a screen to be part of that, because it's tangible, you can touch it, it's interactive in that sense, right? This is where classical designers are trained. Now, since I would say simplified, since the late 90s, we have been talking a lot more about how can we use organization and orchestration of experiences as a design material. And that builds on top of this. So your app and your physical products, they will be part of some service delivery. And that's where service design as a discipline has really come through. We're talking about transitioning from a product-oriented logic to service-dominant logic, where value is in the use of things rather than latent in the product. That kind of discussion is Design 2.0, which works in sync with this. What we're talking about now is a new addition or a new design material, if you will, where we focus on data and computation and artificial intelligence in order to inform the other two design paradigms. So a good designer today, in my mind, will be equally skilled in all three domains. You can still make a career here, and you can make a career here, but I think from the 20s and onward, you will have to deal with this, and we focus on prediction, adaptivity, agency, and systems and services. So how can AI be useful, and how can human-centered design help? So I want to go back to some of the milestones we've seen the last couple of years. These are, some of you will know them directly when you see them, and but I will briefly go through each one of them. Let's start with this one. What is this? Yes, that is chess. Excellent. And in particular, it's IBM Deep Blue beating Kasparov in the 1996 or 7 or something. This was the first time a chess computer beat a human opponent, right? So that was one milestone. What is this? That's, yeah, excellent. It's Jeopardy, but this one is IBM Watson, definitely. For the first time, and for those of you who are young enough to, or young enough to not know Jeopardy, it's a TV talk show with a bunch of questions within several domains. So it's a hard knowledge problem to be able to respond to the quiz here. And here is IBM Watson winning over the two human champions, and they look both, I don't know, defeated, surprised. Anyway, so that's another milestone. And this is fairly famous as an AI milestone. Anyone else? Go. Yeah, let's go. AlphaGo winning for the first time over a human champion, Korean Lee Sedol. And winning in Go is significantly harder than winning in chess because the combinatorial space is huge. So you can't do brute force search. You need to do other kinds of technologies here. Reinforcement learning, for example. Also, why this is a milestone is also because some of the key moves that led to victory was unorthodox. So the human Go masters, they were surprised as of some of these key moves that still led to victory. And Go is a game that has been played for thousands of years. So even though humans have mastered, there was still creativity involved in winning games in new ways, which was interesting. And what is this then? StarCraft 2, exactly. Some people claim it's even more complicated to win in StarCraft 2 than in Go and in chess. I know too little about these three games, but I'm willing, considering my son, for example, in his gaming, I'm willing to accept that this is a very complex game to win. And it's also one of the big esport games, right? And what we've seen now is we have AI bots that can actually beat the best human players in StarCraft, which is also a significant milestone. I'm soon going to tell you why I'm bringing all these examples up. I just want to bring one more up. Do you know this one? Yeah. Enlighten us.
This is actually art that an artist submitted to a contest, and he won.
Yeah.
And he admitted this is AI generated.
Yeah.
And he didn't take the prize.
Right, exactly. But this is Midjourney art that won a competition against human artists. The common denominator in all these 5 is what? AI and beating humans. It's the competition narrative that is being reinforced over and over and over again. This race that AI is competing with us and one of us will succeed, right? And the other one is being obsolete. That's the narrative we are being fed. And my point here is to say that, well, there is of course a risk with that, but I think the value is when we combine humans and AI and augment human activities using the best technology we have. There are a lot of challenges with this, of course. Now, one reason that I think, these are all very impressive milestones, right? And to me, as a designer, just to make things concrete, this is what we design for. We design for a great experience, right? We have the recipe, we have the components, we put it together in a context, and it provides a great experience for the end user, right? But if there's one thing we know, is that reality is fairly messy, right? So even though this is our image when we sit down and we design, we know this will happen, right? This is the world that we design for. What does that have to do with AI? Well, here's a similar thing. During the pandemic, we couldn't sit on arenas like this. So this is one of the lower leagues in Scotland. And what they realized was that during the pandemic, people still wanted to watch the games, but this is a low-ranking league, so they don't have a complete TV crew to film it. So Pixelot, they realized that the task for a computer vision to track a white shape on a green background is a fairly easy computer vision task. So if you train a camera, put it on the center line, and you just say, follow the ball, you can get coverage, TV coverage for all the league games, right? Reality is messy though, so when a referee with my haircut enters the stage, the AI gets confused, right? So the viewing experience looks like this. So it centers on the referee, and then when the player obscures the ball, it immediately finds the next round shape. So, and this is a horrible viewing experience because reality is messy, right? You'd be better off not watching this game, right? Because all the attacks, all the goals are out of view for you. While we can think this is funny, right? But the same thing can also be pretty serious. So if we have medical AI tools that learn, and here is an excerpt from the article, rather than learning medical pathology, the AI models instead rely on shortcut learning to identify association between medically irrelevant factors and disease. And this is something that can harm people. So it's not only making a soccer game less fun to watch, but it's actually putting people in harm's way. And that is not a human-centered way of designing AI, obviously, right? So this is the problem that we're dealing with. And Bill Buxton, one of the principal researchers at Microsoft, he said like decades ago that without informed design, technology is more likely to be bad than good. To kill the argument that technology is neutral, it's only the application. No, it's actually leaning towards bad unless we have informed design. And this is echoed in this excellent book, Human-Centered Data Science. Without a human-centered approach, data science may not only cause irreparable harm, but will also be unsuccessful in its lofty goals. And those lofty goals are, well, of course, human-centered data science will serve humanity. Well, it won't unless we have a human-centered design approach. Why do we think reality is messy? And why do so many things that we build in the lab, why do they fail when we deploy them? So there's this notion of wicked problems and tame problems. It was coined in the 70s by Rittel and Weber, and they made the distinction between tame problems and wicked problems. And you can see it basically here. And I think this tells the whole story of the table, really. Tame problems is the well-defined kind of engineering problem where you can break down, even though they're complicated and complex, they can still be broken down into subproblems. And you solve each one of them, and magically the complete solution falls out, right? That's sound engineering, and it has worked really well. It's nice because they are always objective and measurable, they are predictable, and you can all agree in the room when you've solved the problem or not. Chess is one example. Go is another example. StarCraft 2 is a third example, and so on, right? These are problems that we can all agree that when the king cannot move, the game is won. However, most problems that we tackle in real life are not that kind of problem. Usually, if you can go to any societal issue like health, education, the justice or legal system, crime, immigration, global warming, pandemics, bacteria resistance, nuclear warfare, anything, those are not tame problems. Those are wicked. That means that they are complex, ill-defined. They have multiple context-specific solutions. Most people, well, not most, but a lot of people won't even agree what the solution should look like. And also, as soon as you start addressing the problem, it tends to change. And there is no stopping rule, and there is no way to go back and make a controlled experiment. Imagine making a controlled experiment on privatizing Swedish schools. Well, how can you roll that back and make that again, right? We're stuck in that solution, and we just have to keep addressing the problem, right? So my point here is that design and human-centered design can contribute here. It's not a silver bullet that can solve it, but we have methods that can help address these so that tame problems can help here. And in order to do that, we need interdisciplinarity, we need contextual interpretation, we need qualitative methods, and all that kind of stuff that human-centered designers work with. So an experience-oriented view of AI capabilities, in order for designers and even product managers to be able to provide value here, we can sort of sketch out 3 different buckets where AI can be useful for a company or organization. One is to improve the organization leadership through AI-powered decision making. And this is a very deep point. And I think we as a species, we are an information processing species. Everything we do is about processing information. And that is what at least current AI is optimizing for as well. So we can use AI to augment our own decision making. That is always valuable for a company. Another bucket to put AI into is perhaps what most people think about immediately, is to improve efficiency and precision in workflows. So you can isolate a few workflows and you can say, well, we can automate this, or we can make this more efficient, and so on. And the third one is also perhaps something that people think about. That is to create new, unique type of service experiences that wouldn't be possible without AI. Unlocking the phone with your Face ID, for example, or personalized recommendation, unique for every user. Even if you're, have tens of thousands of users, you can still get personalization and so on. So this is part of a framework that we sometimes use when companies or organizations, they come and say, we have this AI monster here. What can we do with it? Well, one way is to segment. Well, do you want to improve your decision making, or do you want to improve efficiency, or do you want to create new service experience? This is just one fork, so to speak. Now, no matter what you do here, you can listen to Licklider, the thinker from the 60s. And he actually said, in this quote, it is the destiny of computers to become interactive, intellectual amplifiers for all people pervasively networked worldwide. So not only does he predict the internet here in the 60s, but he also says this, interactive, intellectual amplifiers. That's the opposite of automating away humans. That's actually augmenting them to become even better. And note the interactive part. And for me, as an interaction designer, that is really a good quote. This is in the 1960s. A little later, Johnson and Vera, in a famous article in AI Magazine, 2019, said, although seemingly counterintuitive, the more intelligent the technological system, the greater the need for collaborative skills. And what collaboration means here is interaction between humans and AI. And why this is counterintuitive is because we might think that, well, if it's a very capable cognitive system, it would do things on its own. It doesn't need to interact with us. But it actually shows that unless we get some sort of super intelligence that render us obsolete, well, not quite there yet. But until that point, this, just because that it's cognitive capable and has a lot to do in the world, that's why it needs to collaborate with us a lot and communicate with us a lot. So one distinction we can make then is assisting services, agentive services, and autonomous services. And assisting services is what we are mostly used to. And that the design metaphor here is that it is a tool. Most apps that you use are tools that assist you. And you are still responsible for doing all the work, even though it's facilitated by the tool here, right? The autonomy is low, adaptivity is low, but interactivity is high. This is the domain of interaction designers and UX designers. Every time you wireframe an app, this is what you do typically. But if you move towards more cognitive capabilities of a service, you reach this interesting point. And I've illustrated with sort of an AI that sits on your shoulder and helps you. This is the augmentation aspect, right? And it's called teaming. That's when the human and AI are collaborating. And as you can see here, autonomy can be high, adaptivity can be high, and interactivity can be high. I want to contrast that to the traditional autonomous robot, which has low interactivity. Actually, most robots are kept off limits for humans because they will hurt us, right? The industrial robots, they will be in a factory typically. No interactivity, fairly low adaptivity, but high autonomy. You just push the button and it does its thing, right? For me as a UX designer, I'm trying to focus on these because I think this one in particular is both challenging because we have high autonomy, high interactivity, high adaptivity, but also here is where most, if we listen to Johnson and Vera and Licklider, here's where most value can be created. So if we look at this spectrum then, here comes the next three buckets we can talk about when it comes to AI capabilities. One is prediction. So no matter what kind of technology you use, you can use supervised machine learning, unsupervised machine learning, and all kinds of different approaches. But what you want is some sort of prediction using known data, that's the training set typically, to classify or predict previously unseen data, right? This is what you're all familiar with this, I assume. Now, if you personalize this or adapt the predictions to either unique users or unique contexts, then you have adaptivity. So that's the next kind of functionality we can build. Now, if we move towards the agentive services that can take its own initiative and also solve problems without me having to view it as a tool, then the design metaphor is more of a butler, right? But we still need to give it orders, we still need to keep up on its status, and it still needs to be able to communicate with us, right? That's what we call agency. So prediction, adaptivity, and agency are also useful constructs for a designer choosing, okay, what kind of AI service will this be? So just to exemplify, prediction, this is what you all use every time you have a word prediction in your messaging service, for example. This is in Swedish, I apologize, but HL, that's, hälsningar is best regards, right? The likelihood that I'm writing hälsningar in a message after HL is fairly high, right? I could write Hälleflundra, Hälsena and other kinds of things here, but it's not very likely, right? Hälsningar is probably the next word, so it's predicted here by the language model. But did you know that there's another prediction here as well on the character level, not particular word? And that has been part of the virtual keyboard since the first iPhone actually, but we didn't see it because in this case, if you take away this was not part of the first virtual keyboard. If you take away this, the likelihood that S is the next character is very high. So what the engineers at Apple did was that they actually invisibly enhanced the hitbox around the next likely key. That means that if you, with your fat finger, is between S and D, it will default to S because that's higher likelihood. That's why it's manageable to type on a very small virtual keyboard. My point in showing this is that some AI support is visible and some is invisible. You don't have to, in your face, support the user. You can do it behind the scenes a little bit. So that's prediction. Adaptivity, everything personalized in your app is an example of that. You use a user model and you train and you find clusters where similar users to you are put in a bucket and you can recommend things that are good in that bucket, for example. So my start page for Netflix or my lists in Spotify, they will be different from all of yours, right? Now finally, agency then, the third component. This is, and here we come to the point of making the distinction between prediction, adaptivity, and agency and not talk about different AI technologies. Because actually, the agentive user experience doesn't require the most advanced AI. The lawnmower, the robotic lawnmower is one example of that, because the AI in some of these are very low, very basic. It's not even considered AI in some cases, right? It's just you just have the little what do you call it? The little fence that you dig down in your lawn, right? And when a sensor hits it, it just moves away. That's barely AI, right? But the agentive experience is great, because now I can give it the high level order of saying, maintain my lawn, please, and I can do other things. That's the agentive experience. But it still needs to be able to, for example, notify me if it's stuck or if it doesn't find the charging station. I need to be able to tell it, I have a garden party on Friday afternoon. Stay in your shed, please. That kind of interaction is needed even for these kinds of services. So as a designer, your focus shifts, right? Actually, the Spotify compiled lists here that's agentive and adaptive. Because if you think about it, this is like having Spotify make me mixtapes while I'm not around. And then when I open it up, it has served me with 6 new mixtapes. Do you understand tapes? Are you old enough to understand tapes? Good. So this is what I mean by agentive. Spotify is doing things while I'm doing other things, and it serves me with personalized predictions of what I like. And then we have robo-investors, we have thermostats like Nest and so on. So the human-centered design, I apologize for the pixelated image here, but the human-centered design process, this is a mixture of human-centered design and design thinking. Maybe most of you have heard of both those, and this is a combination of the two. Design thinking is basically the steps of empathizing with the user, understand the context they operate in and the goals and the attitudes and so on, in order to be able to define a scope. And within that scope, you can ideate and then you prototype the solutions, right? This is the design thinking process. Now, human-centered design, that's when we talk about, sometimes we call it the double diamond process. That's when you have the diverge step, where you find inspiration for a service, and then you close to in a convergent step. That's the first diamond. When you reach the solution, the problem that you want to address, and then you have a second diamond, exploring how to build this, and then you arrive at a solution. So basically, we tend to say that the first diamond's goal is to build the right thing, and the second diamond's goal is to build the thing right? And also, the human-centered aspect here is that you iterate and you prototype and you evaluate the user experience consistently so that you can gradually get to a better and better product. If you approach, you use design methodology on AI-powered services, you have a higher likelihood to build something that is valuable. Quickly, an example of this then. We were approached by a company who had this camera that could do automatic triage in the emergency room. So if you haven't been to the emergency room, good. But if you have, maybe you realized that they were taking 5 vitality parameters. The nurses, they take the heart rate, the blood pressure, oxygen saturation, respiration rate, and body temperature. In a traditional emergency room, these are all manually taken, and sometimes they don't have time to take all of them. But ideally, all these 5, along with you describing your symptoms, that is what makes them do the triage, classifying you as green, orange, or red. Red meaning immediate care or you die. Orange will keep you here and we treat you. And green, you get a hug and go home because it's nothing really serious wrong with you. The camera that this company had could, because they had done rigorous training and they had 2 camera lenses, one infrared and one regular, they could actually, with a high prediction rate or accuracy rate, predict all these 5 with a contactless exposure for 30 seconds. So a patient goes up, stands in front of the camera, like I'm doing now, and you get the 5 vitality parameters like that. That, of course, can save a lot of time in the emergency room. So the company had this logic. So they said, we can predict vitality parameters. That's what AI can do. And then we push that idea into the context and say, faster triage, that is probably valuable. Let's do it. I'm exaggerating the point here. They were a little bit more nuanced than that. But when I hear this kind of logic, I do this because I think that this arrow, the direction, is not human-centered. It's technology push, right? So what we did was to suggest, well, in order to make this service better, how about we do a design sprint for a week? And that's one of the design methodologies we have within human-centered design, which basically means that on the Monday, you create a team, you embed a lot of different disciplines within it. We have product managers, we have developers, we have designers, we have nurses, right? Because they need to be part of this. And we start by exploring different kinds of user scenarios or journeys. And we interview a lot of people within the healthcare sector, clinic leaders, nurses, and so on. And then on Tuesday, Wednesday, Thursday, we start sketching out and we vote for which ideas we want to explore. And then on Thursday, we start preparing for an experiment that we will run Friday morning. And we build all the prototypes and trappings for this. This is just an iPad with a fake mock-up of all the measurements that we could have. This is part of the nurse's journal system. This is a queue sign we put up in our fake emergency waiting room. At Halmstad University, we have nurse training, so we have these beds and complete treatment rooms that we can use. And as you can see here, the new addition here is this. This is a shoe box that we printed out camera lenses and put on a lamp stand so that the nurse could have this camera using that. And then we had students, of course, to play patients, gave them symptoms. And a few nurses came in on Friday on their free time, I might add, because they were so interested in developing this. So they came in and we gave them scenarios. Here you can see identify patients, it said, and we remotely control this via our control room where we have cameras for the treatment room and so on. So what we had the nurses and the students or patients do is role play a few scenarios using this camera. And this is more like a probe, technical term for prototype that doesn't have a specific purpose, but we put it in there and the nurses could do whatever they want. They knew what it could do, and we just wanted to explore how is this used and also get something to talk about later. So Friday afternoon, we debrief and we discuss and we learn a few things. This is the original. What we are doing usually is that we flip that arrow around and start with what's valuable and we insert how technology is used as part of the mix. And that means that we talk to patients and nurses and we discovered a few interesting things. For example, complete automation means that you miss a lot of things from the nurse's competency. For example, there's this notion of the clinical gaze, which is the tacit, silent knowledge that nurses build up over time. So with years of experience, no matter what the 5 vitality parameters say, a nurse can just by subliminal perception pick up cues that help him or her to assess the patient even better. And that often happens, by the way, when you do this manual, you put on the blood pressure brace and you look them in the eye and you go out in the waiting room and you talk to people. That's the kind of thing that we run the risk of losing with a 20-second exposure to an AI-powered camera. Also, we might lack the patient communication. We might also, because when you put the manual parameter taking, you actually touch the patient. You have a calming hand on the shoulder and you look them in the eye and so on. And that has actually a positive effect on the condition that they suffer from. Furthermore, if we use the camera along with the manual parameter taking, that's the way they went about actually. All of the nurses basically used a combination of it. What we then have is that the camera might take 3 blood pressure measurements or body temperature measurements, and you could make 1 as a nurse. That means that instead of only one data point, you now have a trajectory for over time. Like the body temperature seems to drop and the pulse seems to go up. What does that mean? So you get more feedback, and this actually, we found out in the interviews, they could see that that would develop their skill, enhancing their clinical gaze. So now we have a tool that don't take away from that, but actually adds to the clinical gaze and the skill development. So instead of just faster triage as the original hypothesis, we also get better triage and more competent healthcare staff and a safer patient experience. So everything in green here is what the design sprint and human-centered design approach add to the equation. We still utilize this, and it's still faster. Maybe not as fast as 20 seconds, but it's still faster than only manual. So I think this shows how human-centered design can help both enhance and augment the nurse's professional way of doing things, but also make a better healthcare system. So the framework I want to sort of end on here is, remember these 3 buckets that I talked about? These are the kinds of things you can do with AI. If you combine those with prediction, adaptivity, and agency, most of you can see that there is a nice little matrix here, right? So each of those represents some kind of service or value-adding option and so on that have different flavors. I mean, there's a different thing doing prediction in order to empower people to make decisions compared to an agent that provides a new, unique user experience in a certain domain. And you can do combinations. So if we do for the emergency room case, you can see that we did better AI-powered decision making, improving efficiency and precision, and we're using prediction. There is no user model, there is no agent. This is basic prediction. We use the nurse's ability to make judgments, and we improve the efficiency. So in this particular case, the matrix say that, well, this product is here, or this service is here. So you can use it to analyze things, but you can also use it as a way of generating ideas. For example, if you are within the learning education sector, you might say, well, I want to explore adaptivity in order to create unique AI-powered service experiences. Well, that would be perhaps a personalized learning tool that adapts to individual learning styles, for example. And that sort of gives you an idea what kind of data you need to collect, what kind of service you need to design, when it's going to be used, and so on. So I think with this framework and the human-centered design approach and the power of data, we can remind ourselves that we actually always have 3 superpowers to work with. One is, let's not forget that our users and our customers, they are powerful human beings that they have an ability to act and make hard decisions. And we can augment that by using the power of AI and data-driven prediction and so on. And then also adding the power of human-centered design in order to make this happen. So to me, this kind of circles what I am interested in doing. Now, this has been a very, positive, optimistic outlook on how to use AI for good. But let's not forget that there are risks involved as well. So Cathy O'Neill wrote the book Weapons of Mass Destruction. Really good book, and I think it should be core curriculum for everyone working in this space. But this quote is really telling. She said that data is a digital echo of our culture. So again, data is not neutral. There is always an agenda, an implicit agenda on why this particular data set is interesting or not, why it's been collected, how it's been collected and stored. So data is always in relation to whatever culture it's been collected in. Furthermore, she says algorithms are the opinions embedded in code. That's the same thing. How you as a data scientist or machine learning expert or programmer or even designer tailor the algorithms, that has to do with some sort of opinion. ChatGPT being one example, we have forced it to generate. It doesn't say, I don't know that, right? Because it's a generative, a pre-trained generative transformer it's in its essence to generate a new word. Looking at the left context, it will generate words. So if you ask, if you ask how many, list 10 famous people from, and this is an example I got from Anders Turesson at AI Sweden. He's from a small island or something in Bohuslän. And he was like, list 10 famous people from, and I forget the name of the island. And there are no 10 famous people from that island. Still, ChatGPT will generate 10 names because it will do that. That's part of it, right? So that's an opinion on that algorithm. And to close this, I would say if data, culture, algorithms, opinions, they actually correspond to how you view problems. So data and algorithms, they fit nicely into the tame problem space, whereas culture and opinions are those very hard to, they are complex, ill-defined, subjective, relative, but they are super important. And that's why I think human-centered design is a good complement to the engineering and the programming, so to speak. So in summary, what we've talked about today is we have emphasized the importance of interdisciplinary approaches and human-centered design. Bill Buxton's quote, "Without informed design, tech is more likely to be bad than good." We have talked about human-AI collaboration, focused on judgment and prediction. Humans do the judgment, AI does the prediction, and therefore they can help each other. And I talked about the ER case, so you saw a practical application of it. And also combine prediction, adaptivity, and agency so that we have this framework, this little matrix of where AI could provide value. Have you heard about Amara's law? This is the second last slide. Amara's law states that we as humans, we have a fairly linear way of looking at the world. So if you look at the impact of technology over time, we have a tendency to say that it will develop in a linear fashion. But however, most technologies tend to develop in this way. And that means that in the short run, we have a tendency to overestimate the impact of the technology in our society. That's where we get hype, right? But it also means that we have a tendency to underestimate the impact of a technology in the long run. And this is what Max Tegmark and others are warning us about now. Elon Musk and a lot of thinkers are warning us about this, right? And still we are like lemmings towards a cliff saying, ooh, it's so good with AI, right? We need to be careful here. And I think we need, the more we know about AI, the more we understand and think about it from a tame problem perspective and a wicked problem perspective, the higher likelihood we can stick to the red line here and take appropriate measures. Great. Shameless plug. These are the books that you can read. But at Halmstad University, we also have the Meister program, which are shorter courses that you can do even if you're a professional. So they are virtual, self-paced, shorter. They go for spread out so you can find time. They are structured in 3 different tracks: human-centered design, machine learning, and business innovation. So depending on what your interest and background is, you can pick courses from each of these tracks. Meister.se, and you apply by clicking on the links there. Free of charge, of course, because we're in Sweden. All right. That's it. Thank you so much.
Thank you, Pontus.